Introduction to Custom VPC in GCP. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Today we're diving deep into a critical topic that often confuses even experienced GCP practitioners. What exactly happens when you create a custom VPC, and more importantly, what does not happen automatically? This is a frequent source of issues in production deployments and a favorite topic for certification exams. When you create a custom VPC in GCP, you might assume it comes with certain configurations by default, like internet connectivity or basic firewall rules. But the reality is quite different. A custom VPC is essentially a blank canvas, and understanding what's missing by default is crucial for successful network architecture. We'll explore the key differences between auto mode and custom mode VPCs, examine what default configurations are created. Spoiler: very few, and then tackle an exam-style question that tests your understanding of these concepts. By the end of this presentation, you'll know exactly what manual configurations are required when setting up a custom VPC. Auto mode versus custom mode VPCs. Let's start by understanding the fundamental difference between auto mode and custom mode VPCs. When you create an auto mode VPC, Google automatically creates one subnet in each region with predefined IP ranges from the 10.128.0.0/9 block. These subnets are created immediately and new ones are added automatically as Google adds new regions. A custom mode VPC, on the other hand, starts completely empty. No subnets are created automatically. Not even one. You have complete control over subnet creation, including which regions to use, what IP ranges to assign, and when to create them. This gives you maximum flexibility but also means more initial configuration work. The key insight here is that auto mode VPCs are designed for simplicity and quick starts, while custom mode VPCs are designed for production environments where you need precise control over your network architecture. Most enterprises use custom mode VPCs because they need to integrate with existing IP addressing schemes and avoid conflicts with on-premises networks. It's important to note that you can convert an auto mode VPC to custom mode, which is a one-way conversion, but you cannot convert a custom mode VPC back to auto mode. This is because custom mode gives you the freedom to use any RFC 1918 IP ranges, which might conflict with Google's auto mode subnet ranges. What is created by default? When you create a custom VPC, very few things are actually configured by default. Let's go through what you do get automatically. First, the VPC itself is created as a global resource that can span all regions. This is important. The VPC container is global, but the subnets you create within it are regional. Second, you get default routes to the Internet, which is quad 0/0 via the Internet Gateway, with a priority of 1000. This route allows virtual machines with external IPs to reach the Internet. However, just having this route doesn't mean your virtual machines can actually access the Internet. They still need external IPs and appropriate firewall rules. Third, a route for the overall VPC IP space is created to prevent routing loops. This is an internal route that ensures traffic destined for any subnet within your VPC stays within the VPC. The priority for these subnet routes is typically 0, which is the highest priority. That's it, just the VPC container, a default Internet route, and internal VPC routes. No subnets, no firewall rules allowing traffic, no cloud NAT, no VPN gateways, no cloud routers. This minimal default configuration is by design, giving you a clean slate to build exactly what you need without any assumptions about your use case. Now let's talk about the critical list of what is not created by default. This is where many people get tripped up. First and most obviously, no subnets are created. Without subnets, you can't create any virtual machines. You must manually create at least one subnet in your desired region with your chosen IP range before you can deploy any compute resources. Second, and this is crucial, no firewall rules are created by default. This means all traffic is denied by default due to Google's implied deny all rules. Your virtual machines won't be able to communicate with each other, reach the internet, or be reached from the internet. You must create explicit allow rules for any traffic you want to permit. Third, no CloudNet is configured. Even if you create subnets and virtual machines without external IPs, they won't be able to reach the internet for updates or external API calls without CloudNet. The default internet route only works for virtual machines with external IPs. Fourth, no private Google access is enabled on subnets. This means virtual machines without external IPs can't reach Google APIs and services by default. You must enable this on each subnet if needed. Finally, no DNS configuration is provided beyond Google's default metadata server. If you need custom DNS or cloud DNS private zones, you must set those up manually. Common pitfalls and their solutions. Let's discuss the most common pitfalls people encounter with custom VPCs and how to solve them. The number one issue is when your virtual machines can't reach the internet. This usually happens because people create virtual machines without external IPs and expect them to have internet access. The solution is to either assign external IPs to the virtual machines or set up CloudNet for the subnet. The second common issue is when your virtual machines can't talk to each other. This is because there are no firewall rules by default. You need to create rules allowing internal communication. A common pattern is to create a rule allowing all internal traffic within your VPC IP ranges, though for production you might want more granular rules. Another frequent problem is not being able to SSH into your virtual machines. Again, this is a firewall issue. You need a rule allowing TCP port 22 from your source IPs. For testing, you could use quad 0/0, though that's not recommended for production. Many people assume SSH access is allowed by default, like in auto mode VPCs. A subtle but important issue is when your virtual machines can't reach Google APIs. This happens when virtual machines without external IPs try to access services like cloud storage or BigQuery. The solution is to enable private Google access on the subnet. This allows virtual machines to reach Google APIs using internal IPs, even without external connectivity. Let's walk through creating a minimal but functional custom VPC configuration. First, create the VPC itself with the command G-Cloud Compute Networks create my custom VPC, setting the subnet mode to custom, and the BGP routing mode to regional. Note that we must specify the subnet mode as custom. Next, create a subnet with the command G-Cloud Compute Networks subnets create my subnet, for the network my custom VPC, with a range of 10.0.1.0/24, in the region US Central 1. This gives us a place to put virtual machines. Without this step, you literally cannot create any compute instances. Now for the critical firewall rules. At a minimum, you need to use the command G-Cloud Compute Firewall Rules create allow internal, on the network my custom VPC, allowing TCP, UDP, and ICMP from the source ranges of RFC 1918. This allows internal communication between virtual machines. For SSH access, use the command G-Cloud Compute Firewall Rules create allow SSH, on the network my custom VPC, to allow TCP on port 22, from the source range of quad 0/0. In production, replace quad 0/0 with your actual source IPs or use identity-aware proxy for better security. If your virtual machines need internet access without external IPs, set up CloudNet. First, create a cloud router, and then create the NAT gateway. This two-step process is often forgotten but essential for private virtual machines to reach the internet. Best practices for custom VPC design. When designing custom VPCs, follow these best practices. First, plan your IP addressing carefully. Use a consistent scheme across all your VPCs and avoid overlapping with on-premises networks or other cloud environments. Consider future growth. It's easier to allocate larger ranges initially than to expand later. Second, implement least privilege firewall rules. Start with deny all, which is the default, and only open what's necessary. Use service accounts and network tags for granular control rather than broad IP-based rules. Log firewall rule hits for security monitoring and troubleshooting. Third, enable private Google access on all subnets by default unless you have a specific reason not to. This ensures virtual machines can always reach Google APIs for logging, monitoring, and other services without needing external IPs. It's a free feature with no downside. Fourth, consider your high availability needs from the start. Create subnets in multiple zones within each region. Use regional managed instance groups that can span zones. Design your IP ranges to accommodate multi-zone deployments without running out of addresses. Finally, document everything. Custom VPCs can become complex quickly. Document your IP addressing scheme, firewall rules, routing policies, and the reasoning behind your decisions. This helps immensely during troubleshooting and when onboarding new team members. Now let's look at an exam-style question that tests your understanding of custom VPC defaults. The question presents a scenario where a cloud architect has just created a custom VPC and is trying to deploy a web application. The application consists of web servers that need to be accessible from the internet and database servers that should only be accessible internally. The architect creates the custom VPC, adds subnets in S-Central1, deploys the virtual machines, and assigns external IPs to the web servers. However, they're encountering multiple issues. The web servers can't be reached from the internet, the web servers can't communicate with the database servers, and the database servers can't download updates from the internet. The question asks, what is the minimum set of configurations needed to make this architecture work? This tests whether you understand what's missing in a default custom VPC configuration and what specific steps are needed to create a functional environment. Let's analyze each answer option carefully. Remember, we're looking for the minimum configuration, not necessarily the best or most secure, but the least amount of work to get things functioning. This is a common exam pattern where they test if you know the essential requirements versus nice-to-have features. Let's analyze the answer options in detail. Option A suggests creating only a firewall rule for HTTP/HTTPS from Quad 0/0. While this would allow internet traffic to reach the web servers, it doesn't solve the internal communication problem or the database server's inability to reach the internet. This is incomplete. Option B proposes firewall rules for HTTP/HTTPS and SSH, plus enabling private Google access. This solves the web server accessibility and management access, but still doesn't address internal virtual machine communication or internet access for database servers. Private Google access only helps with reaching Google APIs, not the general internet. Option C includes firewall rules for HTTP/HTTPS from the internet, a rule for internal communication within the VPC, and Cloud NAT for the database subnet. This addresses all three problems. Web servers are accessible, virtual machines can communicate internally, and database servers can reach the internet through NAT. This looks like our minimum viable configuration. Option D adds a load balancer and health check firewall rules to Option C. While these are good practices for a production web application, they're not part of the minimum configuration needed to make things work. The question specifically asks for minimum requirements, so this is over-engineered for the stated problem. Let's summarize the key takeaways about custom VPCs in GCP. Remember, custom VPCs start nearly empty, with just the VPC shell and default routes. This means there are no subnets, no firewall rules, no NAT, and no private Google access. You must explicitly configure everything you need. The minimum viable custom VPC needs at least one subnet to host virtual machines, firewall rules to allow required traffic, since nothing is allowed by default, and CloudNet if private virtual machines need internet access. While optional, it's highly recommended to configure private Google access for reaching Google APIs without using external IPs. Some common mistakes to avoid include assuming firewall rules exist by default, forgetting that private virtual machines cannot reach the internet without CloudNet, not enabling private Google access and then wondering why virtual machines can't reach GCS or BigQuery, and creating overly permissive firewall rules because the restrictive defaults seem inconvenient. For the exam, remember that custom mode gives you complete control, but it also requires complete configuration. When questions ask about minimum requirements, think about what is absolutely necessary versus what is nice to have. Always consider the 3 pillars: subnets for hosting resources, firewall rules for allowing traffic, and routing and NAT for connectivity. Thank you for your attendance. Please consider subscribing to the channel.